Okay, so hello everyone. So when you are in the classroom, so you can type 1 and let me see, okay? Okay, good to see you guys. Okay, today we're going to go through SASMO 2019 real paper. So if you are in the classroom, so you can take out the paper and get prepared. Okay, everyone, if you're in the classroom, you need to get ready for it. Okay, so take out the paper. Okay, we have 3 minutes, before we get started. Okay, everyone, we're going to get started. Okay, today we're going to go through 2019, the real paper. So I think that most of you have already done the paper, right? So did you miss some difficulty questions? If you have, maybe you can, type the question in the chat box, okay? For example, if you think question 20 is very difficult, you can key in the chat box. Let me see. Oh, okay. Somebody say the kids haven't been home, right? Hmm. Okay, no worry. Okay, so you can also ask the kids to watch the playback as well. Yes, that's right. 如果是孩子还没有回家的，你可以让小朋友回到的话，就跟上我们的直播。那如果确实没有时间看直播的话，也可以看我们的回放。OK。So everybody, so right now it's 7 o'clock. Okay, so we will get started. Okay. First of all, I'm going to do a very brief self-introduction. So I am teacher Allison. Okay, right now I teach P4 MHA and I have taught more than 3,000 students online and offline. And so to this year, I have 10 years of teaching experience. Okay, this is something about me. Okay, so let's go to what's our topic today is to go through some difficulty questions in the SASMO paper 2019. Okay, so first of all, please tell me. Okay, so which question do you think is very difficult in the SASMO 2019? Maybe you can key in the chat box. Let me take a look. Okay, I see. Some of you say question 8. Some of you say question 12. Okay. So let's see whether we'll cover this, question in the class, So actually, I have selected a few from the paper because, we only have 1 hour run through, so it's not enough to cover all the 25 questions. So here's the question I'm going to talk about is question 7, 10, 12, 16, 18, 19, and then 21 to 25. So if you have any other questions, so you can leave it to the end. If you have, so spare time, I will go through for you, So now everybody, let's get started. The seventh question. So take a look at the question together. So in mathematics, the product of the first n whole numbers starting from 1 is written as n exclamation mark equals 1 times 2 times 3 times 2 times n. For example, 2 exclamation mark equals 1 times 2. And 7 exclamation mark equals 1 times 2 till 7. So the number of hours in September, can be written as n exclamation mark. So we're going to find the value of n. So first, everyone, if you have done this question, please tell me your answer. Let's see how many of you do it correctly. Let me take a look. If, you have done it, so maybe you can, type your answer in the chat box. Let me take a look. Yeah. I see. Good. Some of you say it's 6. Good job. 小太阳 say 6. Good. Good. Most of you chose B, right? But how do we get the answer? So let's take a look. So first of all, everyone, maybe you can tell me in the chat box. So how many days are there in September? 30 days or 31 days? That's right. It should be 30 days, right? Very good. So now everybody, first of all, you write down September. We have 30 days, right? And one day we'll have 24 hours. So then we can find out the total hours in September. That will be 30 times 24. Everybody quickly key in the chat box. So what is the product of 30 times 24? Yeah, well done. So that should be 720 hours altogether, right? So after we figure it out, so now we can think about, because we know that, so n exclamation mark is follow the pattern in this way. We multiply 1 to end, right? So as long as we multiply from 1, 2, 3 to a number, then we can have, then we have 720, then we'll find the result, right? So now this time we can try one by one. So let's do 1 times 2. Is 3, right? Is 2. And then 2 times 3 is 6. Continue. And then 6 times 4 is 24. And then, so everyone, 24 times 5 is, everyone, you can chat about 24 times 5 is 120, right? So the next one will be 120 times 6 will be 720, right? So now the answer should be 6. So the answer, when we answer, should be 6 and then exclamation mark. N should be 6. That's how we do this question. So question 7, is it okay? Yeah. If you got any question you don't understand, you can key in the chat box. Or you can leave it to the end and then ask together. Because we have a Q&A section in the end. So that is question 7. And now let's take a look at question 10. So for question 10 is actually we need to identify what is the pattern here. So take a look here. So in every figure we can see there are 3 boxes, right? And in each boxes we have different numbers. So who can tell me what is the pattern of these 3 boxes? Or you can tell me, so what is the answer for question 10? So for this question, the pattern is a little bit difficult. Yeah, good. Some of you, so tell me the answer should be A, right? But how come it's A? What's the pattern? So let's take a look, shall we? Okay, so actually the pattern is like this. For the first one, we can see here 3 numbers, right? Okay, so 1, 2, and 2, right? And actually it goes like this, okay? So 1, okay, take it as the first number. 1, okay, squared, and then times 2 equals 2. That means, okay, I square the first number and then times, okay, the second number, and then we'll go to the number on the top. Okay, so now let's take a look at the second one. Let's see whether it goes in this way. So 3 square and then times 4. Okay, 3 square is 9, right? 9 times 4, okay, become 36. So that is the second one. And let's take the last one, okay, to check. So 7 square, okay, that is 49. So 49 times 8 equals 392. Okay, goes to this one. So if you want to find, okay, the question mark, what is it? Okay, that's right. Okay, so we should, okay, square, okay, 5 and then times 6, right? So 25 times 6, everyone. Okay, I give you some time to do the calculation. What's 25 times 6? Very well done. Yeah, it should be 150, right? So the answer should be 8, okay? So for this one, the pattern is a little bit difficult. Yeah, okay, 小太阳, good job. And Li Jingqiu, also good job. Okay, so that is question 10. So for 12, okay, let's take a look at question 12. So the plans for mobile data offered by a company are given below. So plan A, B, C, and D. So which plan offers the best rate per minute? Okay, everybody. So what is your option here? Okay, so if you're going to buy any of the plan, which one do you think will offer the best price? A, B, C, D, which one? Okay, let's take a look how we do it. So for plan A, so we know 20 minutes at $2, right? So that 1 minute will cost how much? So 1 minute, okay, so this time we can use 2 to divide it by 20, right? So we can use, fraction to solve. 2 divided by 20, it is 2 over 20, which can, I can simplify, reduce it, to 1 over 10. So that's first one. And now continue, 15 minutes at $4. So let's see, for 1 minute, how much does it cost? Also we can put it into the fraction form. So, we can also reduce it 1 over 12. And then for plan C here, 60 minutes at $6. So 6 divided by 60, which is 6 over 60. And then reduce it, it can become 1 over 10, right? 1 over 10. So the last one, 1,000 minutes at $9. So 9 divided by 1,000, which is 9 over 1,000. So this time, everyone, we're going to compare which one. So it's the, best price. Always say, which one? That means it's the smallest, among these 4 fractions. So anyone can tell me which one's the smallest? A, B, C, D, which one? As we can tell, A and C, they are the same, right? So this one can eliminate directly. Now we are going to compare everybody. So 1 over 12 and 9 over 1,000. You tell me which one is smaller. So you tell me, so this one is B and this one is D. Which one is smaller? You can chop up. Yeah. Liang Tan, correct. Very well done. Yeah, 小太阳, good job. So definitely, of course, it's 9 over 1,000 is smaller. So the answer should be D. So that is for question 12 here. So for this question, is actually you need to change it into fraction first and then compare which one is the smallest one, right? So now let's continue to question 16 here. For question 16, we're going to find the sum of whole number from 31 to 41. So it's actually an arithmetic sequence, right? So remember, so when we talk about how to find the sum of an arithmetic sequence, remember how we do it. Oh, okay. 梁太, your name is Yi Hao, right? Okay, thank you for telling me. So, everybody, let's recall how we do it. Some of you maybe already forgot, right? So first of all, we need to find out how many numbers are there from 31 to 41. So the first question, you tell me, how many numbers, always say how many terms are there? How many numbers are there from 31 to 41? Okay, everyone, this one I think is easy. You can chop. Okay, how many numbers? How to find out the numbers? Okay, we have taught in class. But yeah, okay, Wang Zhen, that's right. Good job. So we use the last term to minus the first term. Okay, and then plus 1, right? So 41 minus 31, and then plus 1, okay, equals to 10 plus 1, which is 11 number. So that means from the first number to last number. So altogether, we got 11 numbers here, right? Okay, 建峰, very good. Okay, I see. Okay, so, and stars, right? Okay, well done. So after we find out the numbers, okay, then we can use the the formula we have learned, okay, to find the sum of arithmetic sequence. So let's record together, okay? If you forgot, maybe you can put it down. We use the first term, everyone, the first term to plus the last term. Then, okay, remember to times the number of terms, which is 11 numbers here, and then divided by 2, okay, divided by, okay, so here I will put down the number of terms, number of terms, and then divided by 2. So now we can put it down, okay? So the first term is actually 31, and the last term is 41, okay? And then times number of terms you already find out in the first step, which is 11, then divided by 2. So now, okay, let's try to do the calculation. 31 plus 41 is 72 times 11, and then divided by 2. So everyone, first let's try this one. 72 times 11. Okay, how much is it? Yeah, okay. It's your time to do the calculation in one. Okay, I'll start. Your name is Peter. Okay, I try to memorize your name. Okay, good job. Okay, Jing Qiu, very well done. 792. You're the first one. Good job. So here is 792, then divided by 2. So in the end, we have the answer should be 396. Yeah. So the sum of this arithmetic sequence is 396. Yeah, well done, Peter. And well done, Jianfeng. Yeah. Okay, so that is question 60. Okay, so now let's move on. 18. Okay, question 18. Everyone, let's take a look at question 18. So we're going to find the smallest 3-digit number such that the product of all its digits is also a 3-digit number. So first, you need to understand what's the question asking. So this is a 3-digit number. So we got 100, right? Okay, so we know, okay, hundreds, and then tens, and then the ones. Okay, this is a 3-digit number. And then, okay, it says we need to find the smallest 3-digit number such that the product of all its digits. For example, if, okay, the digit on the 100 is A, and then on the 10 is B, on the 1 is C. So we need to find out, okay, the product of the 3 number is also a 3-digit number. That means if I multiply the 3 number, it will be a 3-digit number as well. Okay, everyone, let's take a look one by one. If you want to have the smallest 3-digit number, okay, everyone, this question is so easy for you. Can you tell me the smallest 3-digit number? What's it? The smallest 3-digit number is? What's that? Oh, yeah, good job. A lot of you can tell, right? It should be 100. Yeah, very good. Jingqiu, that is 100, right? But if, okay, so the three number is 100, but is it possible? It says, okay, it is the smallest three-digit number, and at the same time, this three-digit multiply together also a three-digit number. If I multiply 1 and then 0 and then 0, you become 0, right? So that means this one is impossible. So that means how could I make this number as small as possible, and at the same time, I multiply the three number, then you become a three-digit number. Okay, everybody, please tell me, if I keep A as 1, okay, so B and C should be which number? Yeah, let's try 9, right? Okay, so if A is 1, then B is 9, C is 9. Can you tell me 1 times 9 times 9 equals? Equals what? Okay, equals 81, right? Okay, still a two-digit number. So that means I cannot make A as 1. So that means I need to try 2, right? So if I try 2, someone you say, oh, teacher Allison, maybe I will try 299. This time, okay, it's definitely be a three-digit number. But my question is 299 the smallest number? Yes or no? No, right? So we can try. Okay, so this time, we can erase the tens, right? Okay, so we try to make the tens place as small as possible. So tell me, 2 times which number and times 9 will bigger than 100? You tell me. We try to make the tens digit as small as possible. Yeah, this time we can try 6, right? 5 is impossible because 2 times 5 will become 90. 2 times 5 times 9 will be 90. So this one, okay, impossible. So we can try 6. 2 times 6 times 9. Oh, this time you will be definitely be a three-digit number. So the answer in the end is 269. Okay, now how do we do this question? First of all, we can think of the smallest three-digit number and then keep the 100th digit as small as possible, and then make the other two as big as possible to try to find out a three-digit number. If it cannot, then we try the next smallest 100th digit. Okay, and then try to keep the tens place as small as possible so that we can have the smallest three-digit number. Okay, so that is how we do it. Okay, so now this is question 18 and continue. Let's take a look at question 19 here. Okay, let's look at question 19. It says, some children are in a summer camp. If the children are divided into groups of 7, then each child will be in a group. If the children are divided into groups of 9, then 2 children will be left out. What is the smallest possible number of children in the summer camp? Okay, first of all, you tell me what is your answer. Okay, after trying the paper, after trying this question, can you key in the chat box? Okay, what is your answer? What's the smallest possible number of children? Okay, I'll give 30 seconds. You can key in the chat box. If you haven't done it yet, maybe you can. Okay, think about it. Oh. You have forgot. You forgot. Okay, no worry. Okay, if you forgot, okay, follow me. Let's try. So let's see how we do this question. Let's take a look at the first condition. It says, if children are divided into groups of 7, then each child will be in a group. Oh, Fei Li, yeah, good job, 56. And then Peter say 56. Good. Oh, that's right. Okay, everyone, if this number is divided by 7, then each child will be in a group. That means this number must be divisible by 7, right? Is it? So this time I can, okay, make this number in this way. Because it must be the multiple of 7. So it must be 7, 8. Right? Okay, what means 7, 8? It means 7 times 8. Okay, it can be 7 or it can be 7 times 2 become 14. It can be 7 times 3 become 21. So we can put it as 7, 8. That means it is the multiple of 7. And then the second condition is, if the children are divided into a group of 9, then 2 children will be left out. So I use this number 7 times 8, then divided by 9, then quotient, then remainder is 2, right? So it means 2 children left out. That means the remainder must be 2. Is it? Must be 2. Okay, now here comes another question. So if 7a divided by 9 equals something remainder 2, then can you tell me, if I say 7a divided by 9, okay, then, oh, sorry, okay, so here, okay, so if I use 7a plus 2, please tell me, this number must be the multiple of what? 有听得懂吧? 7a divided by 9, there will be a remainder 2. So if I use 7a, minus 2, okay, sorry, here, it should be minus 2. So this number must be the multiple of which number? Yeah. Okay, it must be the multiple of 9, okay? It must, yeah, good job, affiliate. It must be the multiple of 9. Okay, so let's think about it. So that means 7 times a minus 2. It must be the multiple of 9. And let's try, okay? So we can try one by one. Okay, can 7a minus 2 be 9? Is it possible? Is it possible? Be 9. Let's try. So 7a minus 2 equals 9. Then 9 plus 2, then divided by 7. Is it possible? 7, okay, 9 plus 2 is 11. 11 divided by 7. Oh, there will be remainder. So it's impossible, right? So this one, impossible. Maybe we can try the next one. 7a minus 2 equals 18, right? Because 18 is the multiple of 9. Then, okay, so 18 plus 2 divided by 7. Is it possible? Also no, right? Okay, so now we are going to try one by one, okay, until, which one? Until when a is, okay, 77 times 8, okay, 54, until it is 54. Okay, so when, okay, so this one is 54, let's try. So 54 plus 2, and then divided by 7. What's it? 56 divided by 7, which is 8, right? Okay, so that means when a equals a, so this number, okay, must be divisible. This whole number 7a must be divisible by 9. Okay, so now since at first we know that this number is 7a, right? So the original number should be 7 times a equals to 56. So the answer for this question would be 56. Okay, let's review how we do this one. First of all, we need to identify that, okay, this number divided by 7 without any remainder, right? So it must be the multiple of 7. So we can put it as 7, 8, right? And then the second condition gives us that if we divide this number into 9, then there will be a remainder 2. So that means if I use 7, 8 minus 2, it must be the multiple of 9. And then we can enumerate one by one. When 7a minus 2 is 9, when it's 18, okay, when it is 27, step by step, until we try 54, we find out a is 8. Okay, if you are late, no problem. Okay, you can watch the playback. Okay, you can watch the playback. So that is about question 19. Okay, a little bit difficult because, okay, it actually, okay, asks us to find the relationship between the remainder and the number itself. And you need to try one by one. Okay, that's question 19. Now let's take a look at question 21. Because 20 is so easy. Let's try 21. For 21 is actually testing the sum, multiple, and difference. The question goes like this. Originally, there were equal number of tables and chairs in a shop. After selling away 42 tables and bringing in 24 chairs, the number of chairs will be 4 times as many as tables. How many chairs were there in the shop originally? So when we have this kind of question, can you tell me what do we draw to help you to solve this kind of question? Okay, good. When we meet the sum multiple question, we draw model to help us, right? Okay, to transform the abstract thinking into a very direct looking, right? So now let's draw model. First, okay, T means table, okay? And we know that originally there were equal number of tables and chairs, right? And now we can draw it like this. This is a table. And then this is chair. C means chair. C is chair. Okay, at first they got the same amount, right? Same number, equal number of table and chair in a shop. And then it says, after selling 42 tables, okay, then we sell 42 tables. 42, I use another color. Maybe here it is 42, okay? You follow me and draw model together to visualize it. Okay, this is 42. And then, okay, so we bring in 24 chair. Okay, we bring in 24 chair. Okay, maybe here is 24. This part, 24. And then we know that in the end, the number of chairs will be 4 times as many as the table. So everyone, let's take a look. In the end, the table only got the black space, okay, because it sell away 42, right? So in the end, only the black space. And then, okay, after bring in the chair, in the end, we have, okay, the black space for the chair. And now we know that, okay, so the number of chair will be 4 times as many as table. So that means this is 1 unit, right? This is 1 unit. And then it should be, okay, 1 unit. And then 1 unit, 1 unit, 1 unit. It should be 4. It should be 4 times as many as the table. Okay, my question is, so here we know that it is 3 units, right? And can you tell me 3 units is how much? So that means from this part to this part. Okay, that is 3 units. So can you tell me 3 units equals how much? Yeah, very well done. Okay, 适用, right? 适用, very well done. Okay, actually, as you can see, so the blue part, right? The blue part is 3 units. So we can add up. Okay, it's 42 and then 24. It is 3 units. Okay, and then it's 42 plus 24 is 66. And we can find out 1 unit will be 66 divided by 3, which is 22. And let's see what's the question asking. The question asking how many chairs were there in the shop originally. Okay, so we know that the chair is 3 units, okay, and then plus 24, right? Then we can have 22. Oh, sorry, it's just times 4. It's times 4 units, and then minus 24 is the original. original number. So that will be 88 minus 24. So everyone, please tell me in the end. Okay, so what's the result? 88 minus 24. Okay, thank you. Thank you, Phoebe, right? Phoebe Jun, good job. Okay, it should be 44, sorry, 64. 64. So it will be very easy for us, okay, to draw model, okay? So if you don't draw model, it will be a lot of numbers for you, okay? It's difficult for you to find a relationship between the table and the chair. So when we meet this kind of question about sum, multiple, and difference, remember to draw model to visualize the relationship between it. That is about question 21. And now let's move on to question 22. Okay, question 22. Okay, question 22 goes like this. January 23rd, 2019 can be written as 8-digit day format like this. 2301219. And September the 2nd, 2019 can be written as 8-digit day format 02092019. How many digit 3 are there in all 8-digit days of the year 2019? Peter said it's very blurry. Okay, so if you find it's very blurry, it's okay. So after the class, okay, I will send the PDF, okay, the solution, okay, in the parent group, okay? Okay? Okay, so I will send the detailed solution to the group. If you cannot see clearly, no worry. So after it, I will send detailed solution in the group. Okay, so now let's continue for this question. It's asked how many digit 3 are there in all 8-digit days of the year 2019? Okay, let's do the listing. Okay, actually this question is not very difficult, but we need to do the listing. So first tell me, let's take a look at that. We can divide it into 3 parts. First of all, look at the year. Okay, the year is 2019. Okay, from the first day to the last day of 2019, look at the year. Is there any 3 in the year? Yes or no? Is there any 3 in the year? No, right? No. So we don't need to consider the year because there's no 3 in the year, right? And maybe we can think about the months, the second one. Month? Please tell me which month will consist of a 3? Which month? Which month will have a 3? Yeah, March. Yes, very good. March. So we know that March, okay, goes in 03 this way, right? But can you tell me for the month, how many 3 are there in March? How many 3? Think about in March, how many days are there? How many days? Yeah. Okay. Because we know that March is a big month, right? So the big month got 31 days, right? So that means in the months, there will be 31 threes are there. 31 threes. So that's about the month. Okay. And now let's look at the date. For the date, we know that, okay, there are, okay, 20, okay, for 2019. Okay, there will be how many 3 in the date? How many? Okay, I will give you some hints. So first of all, we can think about it. For every month, which day will consist of 3? For every month, which day will consist of 3? Yeah. Okay. Okay. That is okay. So Wang Zhen, that's right. we have day 3, and then day 13, right? And then day 23. Okay, and also day 30 also got a 3, right? Is it? Day 30 also have a 3. And then some of the months will have 31 days. So there is another one. But my question is, how many day 3 are there in 12 months? How many day 3? Yeah, every month will have a day 3, right? So every one month will have a day 3. So that means there will be 12 day 3. Okay, 12 threes. And then, okay, for day 13, every month will have a day 13. Is it? So also 12 3. And how about 23? Also, every month will have a day 23. So still 20, 12 threes here. How about for 30? Please tell me, is every month, okay, does every month has a 30? Yes or no? No, right? Okay, please tell me, which month doesn't have 30 days? Which month? Uh-huh. Yeah, we know that. Okay, February, right? So February, okay, has either 28 days or 29 days, right? So we know that, okay, okay, February, okay, it doesn't have 30 days. So only have 11 threes here, okay? And then how about for 31? So how many months will have 31 days? Okay, thank you, Shi Yong. Okay, Peter, Fei Li, Chen Li. Okay. Jian Feng, very well done. Okay, so please tell me how many months will have 31 days? Okay, and you think about it. So that means the big months, right? The big months will have 31 days. Okay, which month are big months? Think about it. Okay, February is a big month, right? Okay, January. January is a big month. March is a big month. May is a big month, right? July is a big month. August is a big month. October is a big month. And December is a big month. Yeah, very good, Philly. So take a look how many months have 31. It's not 6. Okay. Jianfeng, okay, some of you say, oh, it's 6 months, right? But it's not. It should be 7. Okay, we have 7 big months. So there will be 7 threes here. Okay, because we have 7 big months. So now everyone, this is all the situation that will have threes, right? So now we can add them all up. Yeah, we can add them all up. Okay, so 31 plus 12 plus 12 plus 12 plus 11 plus 7. Okay, everyone, please tell me in the end, how many threes are there in 2019? Okay, everyone, attention. Okay, some of you say only 6 big months. No, we need to know that. Okay, so July and August, these are 2 big months. Okay, these are 2 big months. So altogether, we have 7 big months. Okay, so if we add up, okay, altogether, it will be 85. So for this question, okay, in 2019, there will be 85 threes here. That is question 85. Question 22. Okay, so now everyone, is it okay? So far, so good. If you got any question, okay, you can leave it to the end. There will be a Q&A section for you. So let's take a look at question 23 is number puzzle. Okay, in the following, so all the different letters stand for different digits. So what is the value of the 4-digit number B, D, E, C? Okay, thank you, Jianfeng, Fei Li, Shirong, Jianfeng, very well done. Okay, Jing Qiu, also very good job. Okay, everybody, let's take a look at question 23. Okay, for this number puzzle, can you tell me where should we start? Or what is the cracking point here? Anyone can tell me. So, which letter can we tell directly what is it? Yeah, Fei Li already tell me the answer. Good. But Fei Li, can you tell me, okay, which 1. Can we tell directly what is it? Mm-hmm. Which digits we look at first? C, D, E, B, which one? Okay. So everyone, I want to look at the ones digit first. The special thing is that D plus C give us C. So what does it mean? Can you tell me which number plus another number will be the number itself? What's it? Can you tell me what is D? Yeah, D is, oh, Suyong, very well done. Okay, so because we know that D plus C is C, right? D plus C equals C. So that means D can only be 0, right? Okay, so the first one, okay, and then we can change all the D into 0. Okay, so that's the first one. And now, after we find out what is D, okay, which letter can we find for the second one? Mm-hmm. Do you have any idea? Which one? Okay, I will give some hint. Look at the hundreds place. B plus 0 will be 0. There will be two situations. That is, B plus 0 will be 0. B is 0, right? But can B be 0 again? No, because it says all the different letters stand for different digits. So that means B cannot be 0. Then if B cannot be 0, then B can be which number? Okay, what we can think of, the biggest number for B can only be 9. But 9 plus 0 is 0. Is it? It's not impossible, right? Then what does it mean? If B is 9, 9 plus 0 cannot be 0. That means there must be a carryover. Okay, there must be a carryover 1 on top of it, right? Is it? Yeah, there must be carryover. Or we say regrouping. So then we can write in this way. So that means B plus 0 and then plus the carryover 1. Okay, then equals must be 10, right? So then we can find out B can only be 9, right? Okay, so we solve another letter. That is B, which is 9. Okay, so continue. After we find out B is 9, which one can we think about? Okay, don't forget. Okay, so here, because 9 plus 1 plus 0 equals 10, there must be a carryover on top of the thousands place. Okay, which one can we look at? Yeah, this time we can look at the thousands. Okay, look at the arrow here. We look at the thousands digit. So we know that, okay, so C plus 1 give us 9, right? And then C will be, okay, good. Yeah, that's right. So then C can only be 4, right? Because 4 plus 4 is 8. 8 plus 1 is 9. Okay, we find out C is 4. Okay, we change all the C into 4. Okay, now only one letter left is E, right? Okay, then E will be easy, okay? So we know C plus B is 13, right? And then E must be 3. Okay, so the question asks what is B, D, E, C? Okay, the answer should be, okay, 9, 0, 3, 4 in the end. For the number puzzle question, okay, we need to know where to start. Okay, look at some special place. Especially for example, 1 number plus 1 number equal the number itself. So maybe this is the starting point. And also, if you see some same number multiplied together, okay, there's no carryover. Maybe you can think about, so this number must be smaller than 5, etc. So you need to find the cracking point, okay, in the number puzzle. Okay, very well done. Some of you did very good job, such as Vanessa, Jianfen, Shiyong, okay, Peter, and then, okay, so Yihao, okay, Shramilo, okay, good. So, and let's take a look at this, Wang Zhen, okay, Philip, okay, well done. So, that's question 23. And now, let's take a look at question 24. The question one goes like this. Okay, 4 two-digit numbers are made up from the digits 1, 2, 3, etc. to 8. That means 1 to 8 with no repetition. So that means every number can only use once. And the following are the hints about these numbers. The first hint, in the smallest number, the ones digit is twice the tens digit. Okay, so let's take a look at first of all. The smallest number, okay, I will call is the first, okay, the first number. Okay, this is the smallest. Okay, this is a two-digit number. And then in the smallest number, the ones digit is twice the tens digit. So can you list all the possibility for the smallest number? Okay, anyone can list all the number, all the possible for this smallest number. Okay, I will give you the first one. Okay, so 12, right? The ones digit is twice the tens digit. So 12 is 1. Do we have more? Yeah. The next one we can think of 24, right? 24. 4 is twice of 2. And then we can think of 36, right? And then 48. So here are, okay, 4 possibilities. Some of you say, oh, Teacher Allison, can it be, okay, 5 and 10 like this? No, it's a two-digit number, right? So it cannot be 5 and 10. Yeah. Okay, good job, Peter. Peter, very good job. So for the smallest number, okay, it can be the 4 possibility here. And now continue. For the second smallest, okay, second smallest, okay, it says, it doesn't tell us the second, okay, it says the second largest, but not the second smallest. So I will leave this one here. And now continue. It says the largest number. Okay, this is the largest one. Okay, I put it here. From small to the largest. The largest number, the sum of ones and tens digit is 9. Also, we can list all the possibility. Okay, which two number add up to be 9? Yeah, it can be 1 and 8, right? And also, I can swap the place of the ones and the tens and then make it into 81, right? Okay, can we have more? Yeah, 27 and 72, right? And then 36 and 63. And then 45 and 54. Okay, here are all the possibility for the largest number. And okay, the third hint is in the second largest number. The tens digit is 5 more than the ones digit. Okay, so the tens digit is 5 more than the ones digit. So what can it be? If the ones digit is 1, the tens digit must be 6. And if the ones digit is 2, the tens digit must be 7. And then if the ones digit is 3, the tens digit must be 8, right? But can it be the ones digit is 4 and the tens digit is 9? Is it possible? No, okay, because the number is within 1 and 8, okay, so cannot be 9. So this is all the condition, okay? And now let's take a look at the last hint. It says there is only one odd number among these 4 numbers. Okay, only one odd number. So everyone, take a look. We can try together. Okay, let's try one by one. If the smallest number is 12. If the smallest number is 12 and the biggest number is 81, is it possible? Everyone? Is it possible? Yes or no? No, why? Because every number can only use 1. So that means this one is impossible. Okay? And then we can try another one. Okay, maybe try, okay, when the smallest number is 24. And then, okay, so the second smallest is 72. Is it possible? No, 2 used twice. Okay, but maybe we can go back to 81, right? We can go back to 81. Is it possible? Okay, if the first number is 24 and the second one is 81, and then next one we can try. Some of you, Teacher, listen, can I try 61? Cannot. Why? Because 1 already used, so cannot be 61. Okay, so now That means this one is impossible. Maybe we can try the next one. Try one by one. Okay, 36. Okay, so the smallest number is 36. And then we can try 81 again. Is 81 okay? Okay, 81. If this one is 81, we can try 61 is not okay. And 72 is okay. 72. Okay, and it says we have already used 3, 6, 7, 2, and 81. And which two number haven't used? These two number. 5 and 4, right? So this number must be what? Okay, 54. Okay, 54 or 45, right? But which one is possible? Is it 45 or is it 45 or 45? 54 or 45? How can I tell? Okay, please use the last hint here. It says among the 4 numbers, okay, only one odd number. And then, okay, so if the largest number 81 is already an odd number, so that means the rest of the number can only be even number, right? So the final answer should be 54. So for this question, how we do it? We can list all the possibilities according to the hint. And let's see which one is possible. Okay, so in the end, we can see 54 is the only possibility here. Okay, so the answer for this question is 54. Remember to use the last one, the last condition. Yeah, okay. Well done, everybody. So now this is question 24. And now let's take a look at the last question. Everyone, it goes like this. Okay, Tom had the Lego blocks. He lost 4 pieces at home and then gave 1/4 or is it a quarter of the remaining to his friend Gary. After that, 3 pieces got lost. Then he gave 1/3 of the new remaining to another friend, Fiona. Another 2 pieces were lost. And then he gave half of the new remaining to his brother. At the end, Tom has 19 Lego blocks left. How many Lego blocks did Tom have originally? Okay, everyone, for this question, let's take a look. How can we do this kind of question? How? Okay, so here I give you some hint. We can draw the tree diagram to help us. What is the chain diagram? Okay, if you don't know, you follow me and draw the chain diagram. So the original, number of Lego, we don't know. So I put a question mark here. And then, you draw an arrow, step by step. He lost 4 pieces. Okay, he lost 4 pieces at home. So that means this number minus 4, right? And then become the new number. And then he gave 1/3 of the remaining to his friends. Okay, everyone, this time my question is, if he gave 1/4 of the remaining to his friend Gary, tell me how much does he have left? Yeah, this time he should have 1 minus 1/4, which is 3/4 left, right? So then this number, the second number, multiplied by 3/4, then will become the next number, right? And then continue. After that, he lost 3 pieces again, okay? Then he gave 1/3 of the new remaining to another friend, Fiona. So please tell me, after giving 1/3 of his new remaining, please tell me how much he have left. Yeah, it should be 1 minus 1/3, which is 2/3. So then will become the next new number. Okay, continue. Then lost 2 again, become the new number. And then he gave half of the new remaining to his brother. So after he gave half, he will have half left, right? So times a half. Then equals, it says at the end, Tom has 19 Lego blocks left. So in the end, the answer should be 19. So that is the whole chain diagram. So, but how can we find out the original number? What should we do? What kind of method can we use? Okay, we can work backwards. Everyone put it down. We work backward to find out the original number. So now let's do step by step. Okay, so we know. Okay, so this number. Okay, let's take a look at the first one. No, this one. Okay, I use the blue pen. So this number times a half will equals 19. So can you tell me what is this number? Yeah, okay, it should be 19, right? 19 times 2 will be 38. So this number should be 38, right? Okay, and then continue. Which number minus 2 will be 38? Which number minus 2 will be 38? Yeah, okay, that's 38 plus 2 equals 40. So this number is 40. And now we know which number times, okay, 2 over 3 is 40. So that means, okay, this number is equally divided by 3 parts. And then we take 2 parts out of it. Then we'll have 40. So what is this number? I think this one will be a little bit difficult for you. So what is this number? Which number times 2 over 3 equals 40? That means this number is divided into equally 3 parts. And then we take 2 parts of it. Then we'll have 40. So that means 40 is 2 parts of it. That means 1 part is 20. And then we have 3 parts times 2. That will be 20 divided out. 40 divided by 2 is 20. 20 times 3 will be 60. So this number is 60. Okay. 60 divided into 3 parts. And then we take 2 out of it. That will be 40. And now, which number minus 3 will become 60? Easy, right? So 60 plus 3 will become 63. So this one is 63. Okay, continue. So which number times 3 over 4 will become 63? That means this number is equally divided into 4 parts. And then we take 3 out of it. And then we become 63. Okay, we should use 63. Then should be divided by 3. Because 63 is 3 parts of it, right? And then 1 part will be 21. And then it got 4 parts originally. So it times 4 equals 84. So this number is 84. And then, okay, which number minus 4 is 84? Okay, plus 4, that is 88. So we work backwards and then we find out the answer should be 88. Okay, 88. So that is all about today's question. So for today, I go through, okay, maybe half of the question of the SASMO paper. So everyone, okay, do you have, okay, any other question that you want me to go through as well? If you have, okay, I will give you some time. I give you 5 minutes. So you can key in the chat box. So which one do you want me to go through as well? Any other questions? Okay, somebody said question 3, right? Okay, Ken, let's take a look at question 3, okay? Okay, I will show you question 3 as well. Okay, question 3, this one. Is that this one? Okay, I see, say, Xiao Taiyang say question 3, right? Okay, and Peter say question 8. Okay, Ken. Okay, I will go through question 3 first and then go to question 8, okay? So take a look at question 3. It says in the 3-digit number 2 and 4 is divisible by 6. What is the smallest value of the digit m? So this question is testing the divisibility. Okay, so now everyone, we haven't learned the divisibility of 6, but we know 6 is actually equals to 2 times 3, right? So as long as this number is divisible by both 2 and 3, it can be divisible by 6. Okay, and then we take a look at this number, 2 and 4. So the ones digit 4 is an even number, right? So we know that, okay, put it down, divisibility of 2. Let's record together. So we know, okay, which digit will determine whether a number is divisible by 2 or not. Yeah, the last digit, right? Okay, always say the ones digit or the ones digit. If the ones digit is 0, 2, 4, 6, 8, then the whole number will be divisible by 2. So since we can see this number is end up with 4, so it must be divisible by 2. So we don't need to care about 2, right? Okay, that means we only need to consider divisibility of 3. So divisibility of 3. Okay, so can you tell how to find out a number whether it's divisible by 3 or not? Okay, we look at the sum of digits, right? Remember, we add up all the numbers on the digit, and then if the sum of the digit is divisible by 3, the whole number can be divisible by 3, right? So 2 plus m plus 6 equals a plus m. So that means we need to make sure a plus m is divisible by 3. Okay, so can you tell me? Then m can be which number? You tell me m can be which number? Yeah. Oh, sorry. Okay, so here, is it? Oh, yeah. 2 plus, oh, sorry, here, I make a mistake here. It's not 6. Okay, 2 plus 4. Okay, here is 4. My mistake here. Is it 2m4? Okay, 2m4 plus 4 equals 6 plus m. So m can be what? Yeah, m can be 0, right? Because when m is 0, so 6 plus 0 is 6. 6 is divisible by, yeah, is divisible by 3, right? So then m can be 0, and then m can be 0, and every time we add up 3, the next one can be 3, and then 6 and 9. So the question is asking what's the smallest value? The smallest must be 0, right? So the answer for this one is 8. Yeah, okay. Thank you, Ginny. Thank you, Billy. Okay, thank you everyone for staying behind. Okay, so this about question 3. And now, just now, okay, Peter said question A, right? So let's take a look at question A as well. So I think question A, you can find okay, find a row, okay, and try. So which of the following will form a knot? Okay, when the two ends are pulled away from each other at the same time. So we can take a look at it one by one, right? So let's take a look at A. So it goes in, okay, it goes like this, okay? Then like this. So will it form a knot? Take a look, will it? You can think about it, will it? No, because it doesn't go through a hole, okay? So it's no. So, and how about B? Oh, B is easy to tell, right? No. And how about C? Okay, the end of it need to go into a hole. So is this one? No, right? No as well. Okay, how about D? Will each end go into a hole? No, right? Still no. Okay, the last one. You see, this end is actually go into this hole, right? You can see, of course, in the end, you will make a knot. So the answer should be E. Okay, so that is about question A. Any other questions? If we don't have any other question, then okay, that will be the end of today's class. Okay, I will stay here for another 3 minutes. Okay. No? Okay, good. So then that will be today's lesson. Okay. Okay, later I will send the detailed solution. Okay, in the chat box. If you got any question, you can ask your teacher for help. Oh, Peter say 14, right? Can. Let's take a look at 14. So if you don't have any question, okay, you can just leave, okay? 14, did we go through 14 in the class? 14. Why I don't have 14 here? Oh, let me take a look. Do I have 14 here? Oh, uh, let me take a look. Oh, I don't have 14 here. Okay, I didn't put 14 on my slide. Okay. Did I delete that page? Okay, so Peter, no problem. Okay, so later I send the detailed solution in the parent group. Okay, you can download it and see how we do question 14, okay? Because I don't have question 14 on my slide here. Can? Okay, bye everybody. Okay. Bye-bye. Okay, so I will see you next time. Bye everyone. Bye everybody. Bye-bye.